New piece of equipment on the bench today, new to me at least, not new in itself by any stretch of the imagination. It is a Tektronix handheld auto-ranging digital real-time scope digital multimeter thingy. It has a digital multimeter on the side and the scope 2 channel on the top there. So as for the work that needs to be done to this, first up, the screen is bad. You can probably see this kind of like stuff going on inside the screen. Common to the TDS 210s and 220s as well is the polarizing layer goes bad. Something to do with the glue or the plastic. It deteriorates, smells like vinegar, it stinks, and it goes all foggy and gross and you can't see through it. So that screen will be repaired. This also needs to be repaired. This is the cover for the battery compartment. Very common that the metal part comes loose because these tiny little heat staked tabs, little pins there, they break and then the thing just comes off. Also upgrading the backlight to LED. Even if I buy a new screen, I might do that anyway because the LEDs are going to be more power efficient than the CCFL and be like a nicer, brighter color, brighter white. So I'll get longer battery life and a nice bright screen. The BNCs on the top here also, they're usable, but I don't know if you can see. Let's even focus on that. You can see there's a notch taken out of that plastic bit there. These are made of plastic so that they're isolated. If I go to the other side there, maybe you can see if there's a bit of a notch taken out of that one too. So what happens is, because it's plastic, it wears out and they need to be replaced, but they can't be replaced. Well, they can, but you got to replace the whole part of the plastic chassis. But yeah, so that's pretty much where we're at. So we'll plug it in and see how it turns on. I'll show you what the screen looks like with it in the bad state it is, and then we'll take it apart and have a look inside. Okay, so our jack goes in there. I'll turn off some of the lights. There we go. And it's basically unreadable. Yeah, you can just see the writing on the screen there. It's, yeah, pretty bad. Alright, so let's unplug that and open it up. There's 4 screws on the back. They're like a combination of a flat screwdriver and this is a T10. I guess that's, maybe it's a T15. Where's my T15? There it is. Yep, it's a T15. Torx. Now these screws actually screw directly into the plastic. They don't have metal inserts, like brass inserts. So one thing you've got to be aware of is when you screw these back in, don't just screw them straight in. Put the screw into place and then rotate it backwards as if you're undoing it. And you'll feel it click. Right there, I don't know if you can hear that. And then screw it in. That way what you're going to do is you're going to screw the screw thread back into the original like thread that's been cut in the plastic when the screw was originally installed. And your plastic won't get like stripped out or anything. If you just screw it in however it sits and you start cutting extra threads, you're going to weaken the plastic and eventually it'll just strip out. And that's not going to be any good at all. Alright, so front cover is off. We've got our membrane there. That could do with a little bit of a clean. Not looking too bad anyway. We'll take the strap away. Alright, and there's our, it's like a shield and it holds the front panel membrane switches. Oh, look at that. 3K max. I wonder if that's a quality control thing. So I guess they print the carbon down onto the this Flat Flex cable, or this Flat Flex PCB. There's another one here, 3K max. I guess they'll then measure that to make sure it's no higher in resistance than 3 kilo ohms. And then that will determine if there's been enough carbon laid down or if it's the correct specifications. There'll be just a quick boop boop to make sure that it's passed or not, I guess. That's my guess anyway. So you can see here, We've got the LCD, of course. We've got the backlight inverter here. We've got a jumper there. That'll be for calibration mode. So you jump it over to calibration mode, and then once you finish calibrating, you'll jump it back. Connector for the battery connection. We'll get rid of that because that's got to be out of the way. Let's see how we can pull this out. Oh, yeah, there we go. It's got rubber around the sides for shock protection and whatnot, and to keep it nice and firm in the case. You may find it has a bit of stiction because it's been up against the plastic for however many years. So just be careful when you're taking that out. So there's the inside of the case. You can see the spring there for the back of the batteries, and then there's the contact on the side, the red one there. But yeah, that's basically how it's set up. Alright, so now we've got the PCB here. So to remove the PCB, we're going to have to unplug the LCD from here. It's got two little tabs either side, and you can gently pull that cable out. Be very gentle because it's a flat flex cable and it is delicate. We've got the two connectors for the BNCs, the Patola connectors, invented by Mr. Patola. So you can see there, it's like a little mini plug-in coax. I do like them. They're pretty good. Cheap as chips. Keep the braid and that right down to the connector there. And then you have connectors in the back of the BNCs, and you have ones on the PCBs as well. They're pretty common in tech gear. They work as long as you're careful when you plug them in and keep the center pin there straight. Yeah, very, very compact, which means they can go into small places and do the job quite well without having too much space being taken up, like with an SMA connector where you need to screw it on and all that sort of gear. They just plug straight in. They're pretty good. Tektronix has used them for many, many years. Alright, now we've got to disconnect the backlight cable there, and once we lift it out, we can then disconnect the connector for the front controls there. Now there's a few tabs. There's one here, there's one here, here, and here. One at the bottom, so that's 5, and there's one in the middle as well. And then this board will kind of lift out this way. So I'm going to just lift this up and undo the tabs as I go around. All right. You kind of got to work it out a little bit. Get the screen out of the way, that just lifts out. So I'll get that out of the way, I don't want to break that. And this should be coming out. Oh, of course, that's why. The connector for the battery. There we go, that was holding it there. And then if we lift that out, be careful, be careful. You can disconnect the multimeter binding posts, or the banana jack, sorry. And there is our internal part. This is what has to be replaced, this whole section, if these are broken or if the BNCs are broken. So, yeah, I wonder if I can just kind of like cut them off and then put new ones in. We'll have a look at that later on. And then here is our circuit board. So carefully, carefully remove that one. Make sure you try and lift it out all at one go. Don't twist it sideways or bend it or tear the membrane. And that is the scope, the heart of the scope, I guess, all the guts. Input hybrids, got some power supply gear going on up here, there's a transformer there and some smoothing capacitors and whatnot. Beeper, processor chips. That there is our flash chip. That one there. That's holding the firmware and the calibration. A few National Instruments sort of stuff there. Motorola there. Maxim. These are all, looks like they're branded, or not branded, but they're custom tech part numbers there. So they'll be like the unobtainium parts. Well, there's a relay. It's probably range switching or something. Oh, there's a few more bits and pieces on the back there. Looks like some RAM there, maybe. Yep. all the input gubbins. Yeah, no worries. But yeah, that's basically the scope in a nutshell, or actually cracked out of its nutshell. All the bits and pieces. Regarding this battery lid, this may have been designed with the possibility of using standard C-cell batteries, but they never implemented that. The reason I think that is because it's sized for C-cell batteries. It's got the nice spring terminal at the bottom. It's got the metal cap rather than just plain plastic. And look at this little detail here. That little bit just there. Hopefully you can see that in the light. I think that is for a little metal tab. And what happens is, when this lid goes in, the metal here turns around, and that sticky outy bit there will contact the metal tab that's sitting in there, and then you have the wire going to the positive. So what I'm going to do, I'm going to get a bit of metal, maybe some nickel or something, bend it up and see how it goes, because that would be fantastic if it works. It looks like it's been designed for it. Because if you weren't going to put anything there, having that molding there is a little bit redundant. It doesn't really provide any kind of extra strength. Just there, it's like a little bit cut out. Maybe you can see it just here. There's a little bit of a cutout there. It's not the same thickness as it is here and here. So it looks like the metal is meant to bend around to there. And then that sticking outy bit on here slides past here, and your metal tab can come up to here, and it's got like a return on the side of the plastic, so that will help to hold that little bit of metal in there, because it'll be like bent around like a bit of a springy bit of metal, and then you can have your wire coming off the side and going down. I think that's what I'm going to do. I'm going to make my own little battery terminal for there. So here we have a photo of the battery terminal all finished, ready to be installed. I'm actually going to show some slideshows and whatnot, just some still pictures of the small parts in this video. I think it's going to be easier than having my shaky hands waving the thing around in front of your face. Photos just can be nice and crisp and in focus and whatnot. So I will show a few slideshows here and there so you can really properly see what's going on. So this here, as I said, is the battery terminal all finished. I went to the hardware store, bought some 0.35mm thick nickel plate, and cut it out, bent up the shape, and filed it into the final dimensions. In the links down below, you'll find the plan, the drawing of the shape you need to cut out, and yeah, just bend up like I've shown here, and get your rat's tail files, file it till it's perfect, nice snug fit in that little the little shape in the enclosure, and you should be fine. So once you've got that done, once you've pushed it into position, it should look like this, and then we can run the wire. So this is the photo of the wire running in its way around to the positive battery terminal. It looks like there's little tabs to hold the wire, as you can see, as it loops around. So yeah, it definitely looks like the engineers originally thought about having this compatible with C-cell batteries, and for whatever reason they went with a rechargeable battery pack and did away with the extra parts that we've now added to allow the use of those standard C-cells. So once you've got all that set up as shown in this picture, you're pretty much ready to use your standard C-cells. Alright, for this battery cap, I've come up with an idea. I've got the old JB weld and filled up the inside here with JB weld so I could have enough meat to drill some holes and tap them out. For the area here, you've got to leave a little bit of open area, and that's so that the strap can go in. And to keep that area open, when I was JB welding it, I just cut a piece off with an eraser and carved it to a slight curve with a little notch for the bump in there, and then stuck that in there, and then JB welded around it. Once it was dry, I was able to just cut the small amount of JB weld that's got up the side and then pull that out, and it was fine. So that's all been sanded off smooth, and be careful when you're sanding it, because that little pip, the little bump there that this hooks onto, is taller than the outside here, so you can't just kind of like sand it on something. You got to sand around it. And then drilling out those holes, go in maybe only about 3 or 4 millimeters, and then you can tap it out with well, I tapped it out with an M2 tap, so I can use some M2 by 4mm long countersunk or flathead screws, and then I countersunk the piece of aluminium, the stainless steel plate there. So I'll just put that through the slot, and then that will hook on. The little strap will hook onto the little pip there, the little tab in there, and then that can be screwed on. I'll put some super glue in those holes and then screw the screws in, and that should be a pretty much permanent fix. Alright, so I've put it back together to test this battery, the battery setup. I haven't replaced anything else, the screen's still messed up, so ignore that for now. We'll see if this whole setup works. So I've got some freshly charged batteries. We'll throw those in there, standard C-size batteries. Put the battery door in. I'll turn the lights out because this screen being rubbish, it'll be much easier to see with it dark. Alright, let's hit the button. Oh, I saw a flicker of life. Give it a second, and it looks like we have got power. There it is. You can just see some writing there on the screen. So that is working. Those batteries, standard C-size batteries, are now working in this unit. Fantastic. Alright, time to replace these BNCs, and I think I've got it worked out. So the official word from Tektronix is if the BNCs were damaged or the banana jacks were damaged, you replace that whole piece in one go. There was no separate parts for the BNCs or the bananas. They didn't sell them separately. However, I have found the original manufacturer for these. They still make them, and you can. It looks like you can just press them out and press the new ones in. Details on the screen now. The only difference is that the little post at the back, these ones have grooves on them to help retain the little clip, whereas the ones directly from the manufacturer don't have those little grooves, so Tektronix must have had that modified. I don't think it'll make much of a difference. You should be able to just push them on, they'll probably stay there, but if not, maybe a dab of solder or something on there and they'll be fine. So I'm not going to touch those though because mine are fine. They're not a problem. It's the BNCs we're looking at. So I found these insulated connectors. Nice ones there. From, how do you say that? Staubli, whatever, however that is. I'm going to say Staubli. And these cost like, I don't know, I think I paid $5 each for these. So they're not too expensive. And they seem to be an almost exact copy or exact same, like everything internally as the Tektronix ones. Obviously the mounting is different, but these look like to be the ticket. So what we're going to do is we have to cut off the schnoz on the front there with the two little pips, this whole section, and it's going to expose the metal part inside, which I've got here. I've already done this one. So that's the front where you're going to normally connect your probe, and this is the back where it goes into the scope. So it looks like what they do is they push that in from the back into the housing, and then there's this clip ring that goes in. So when we cut that schnoz off, which we have to get rid of anyway, that's going to expose the metal, and we can use a G-clamp, and I'm going to use a nut, oh not a nut, I'm going to use a socket here, and then that will let me push that out and leave me with a nice little cylindrical hole going through where that metal part used to be. And that is almost exactly the right size to then tap that out and screw that directly in. So the first one I actually pulled the BNC out of the housing because I wasn't sure exactly how it all worked. But so I'm going to have to glue that in. But it is firm, but I'm going to have to put some glue in there to make sure it's all tight. But I'm going to do the second one in place so that the original clip, kind of the way it's clipped in there, is all retained, and it should be really perfect. So first up, we're going to have to cut off the nose, the schnoz off the front, carefully so don't cut your fingers off. You just kind of ring bark it. It's pretty soft plastic, so it should come off relatively easily, just like that. So now you can see the metal part, right? We need to push that way. So if I get my G-clamp, put my socket on the back there so that you can push that center part into the socket. Alright, is it going to be big enough? Yes, it is. Cross our fingers that this is going to work. Might be a little bit interesting. I might have to go off camera just slightly. I've got to go off the edge of the table here. Alright. Yep, there we go. I got it. That's gone in. You can see it's pushed in there. There's our little retaining ring. And there is the center part. So that is now a nice hole ready to be tapped out. There you go, you can see that there. So we tap that and screw that in, and we've replaced it. So the thread looks like to be a 1/8 inch. I've got a 1/8 inch BSP 28. If I'd start that off there. Now, being plastic, I want to be a little bit careful to make sure it doesn't like get all sticky. I'm doing it by hand, so it's not going to really melt, but I don't want to cause any problem with it sticking and then ripping the that kind of ring in there and causing it to spin, because then I'm going to have a problem with it not holding in there properly. So I'm going to go through back and forth. So we slowly cut our way through. Alright, I think I figured out the next step. So we need to figure out a way to connect the BNC to our fly lead, which goes to the PCB, right? So these are using a Peltola connector. The only problem is that you can get the PCB mount socket, or you can get the jack, which goes on the or the jack assembly, which goes on the cable, right? You can't, that I can see, you can't easily get a inline socket that goes on a cable. So what I've done is I've put an SMB on instead. So you've got SMA, SMB, and SMC. SMA is what you'd see on the antennas for your Wi-Fi router and all that sort of stuff. It's like a little hex nut, and you screw it on. SMB is a push-on. There's no screwing required. You just push it straight on. And then the SMC has a push-on, and at the end you screw it to fasten it there. So I'm using SMB because I just want it to be a push-on, just like the Peltola style. And that looks like it's going to work quite well. So basically what I've done, this is an unmodified one and this is a modified one. I've drilled down through the middle of this extension part here, 1.3 millimeter, drilled in about 14 millimeters from the very end. This is really long because of the electrical isolation. So it can be very high voltage isolation. We only need it to like 300 or 400 volts as rated on the back of the scope, and I'm going to put the glue heat shrink there as well. So I've cut that right back. After I've drilled the hole, I've cut the plastic right back, so it's only a few millimeters sticking out of the black housing, and then a few more millimeters I've cut the brass section. And because I've already drilled the hole is there ready, and then I stick the SMB connector so that it's in and it mates together. Bit of solder, and that's on there. Straight through connection. A little bit of the glue heat shrink is then slid over, and it's size, so it pushes down into the right down into the connector there, and then also comes right up to the back of the SMB. And that way, when I heat shrink it, the glue squeezes out, glues up, and it helps keep that isolation between the center and then the outside as good as you're going to get for an SMB connector anyway. So once that's done, then you can see the little jumper wire there from the tab across the outside of the SMB. And then finally, just for good measure, I'm going to put another piece of glue heat shrink on there, and then we're done. That can then screw into our housing. And we've got a new BNC and converted to SMB. Okay, now we've got to connect these BNCs to the main board here. That won't plug into that, same here. So I've got these from eBay, just a SMB male to SMB female. Little cable there, so that's going to plug onto there. And then I'm going to solder it down to there. And that should give us our disconnectable connection. That is also soldered as it is by factory. And there we are, all in there. Nice. SMB connectors down there, make sure they're pushed on properly. You'll find that when you put this board in, they're going to touch, there's an opto couplers or something just underneath here. Before you put the board in, make sure you just support it there and kind of push the connector, the one that's on the BNC, push it down to kind of like bend it down. The bit of like metal or whatever through here, it's brass or something, it's pretty malleable. You can kind of like push it down and bend it and it will be okay. And that will mean there's a decent amount of clearance when you plug that SMB connector that's on the cable in, and it won't contact the parts on the other side of the board. So make sure you do that. And then once you plug it in, you can wrap it around and then around. And you can see there I've crimped on the old crimps, if that's going to focus. So I just use my tiny little side cutters. You can use something similar just to open up the crimps, like the where it's bent over onto the insulation and over onto the shield there. And you can open it up and then pull the old one off, and then just cut the new cable to the same dimensions, the same lengths as the old one. Stick it in there and then carefully bend it back over with your needle nose pliers, and it comes up pretty good once you soldered it back in. Both of them there. Make sure also you plug that on properly, and then before you put it together, just do a continuity test between the center pin and the center conductor there to make sure that it's got conductivity, so that you don't put it all back together, find out it doesn't work and have to take it all apart again. PCB wait time, of course. We got some delicious fresh PCBs delivered today. We'll talk about these ones in just a sec. But first, we have got our LED driver PCBs. Full disclosure, this isn't my original design. I mean, the layout is, but the actual the schematic or the circuit design is based heavily off someone else's design on the EEVBlog forum. Link down below, full attribution, standing on the shoulders of giants. And yeah, there's a member there. He came up with the original design of the LED driver for these scopes, and I've taken that and run with it and done my own take on it, my own spin. So we've got a, you can put a trim pot here if you want, and you can dial it in with your tongue in the right position and your lucky socks on, get it the right brightness, or you can just put fixed resistors if you want to just get it to a value and leave it at that, and don't do any tweaking anymore. So looking pretty good compared to the original. Pretty much exactly the same size. And I went and did some nice curvy traces and stuff just to make it artistic and, yeah, beautiful looking. Looks good. So before we get those together, let's have a look at these ones. I'm pretty happy with the way these turned out. I ordered 5, they gave me 6, which is a bonus. Fantastic. Sometimes you get a lucky bonus like that. So what's happened, the reason I need these things is because this one's failed. As I was playing around with these scopes, plugging in and unplugging this Flat Flex, it actually fractured the traces in here. So these aren't actually copper. They're like some sort of conductive ink, like a silver ink or some sort of conductive ink. And yeah, they've all, like a bunch of them are fractured. You can see I've got the crosses here when I was testing them, figuring out which ones were bad and which ones weren't. And I tried to like scrape back the plastic coating, but the ink in there is so fragile it just scrapes away, and it's just, yeah, not repairable. So I made my own design. Da, 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 da. Look at that. The original one is like that conductive ink stuff and the carbon pads. This one is copper traces and gold plated pads. I also went to the trouble of putting all the button names on the board there, so that when you've got it open you can easily see what the buttons do, so you can play around much more easily. I've got some pins here which I will be putting onto the edge of the PCB there to replicate these pins. And on the back we've got the adhesive already applied. So I'll get the heat gun and peel this off, slap this one on, blip, like that, with the edge pins, and then that will be ready to go. Fantastic. I am really happy with the way that turned out. Look at that. Great. Alright, time to look at this Flat Flex. So I've already soldered the little pins on there. You can see there on both sides. Because what I've done is the pads, I put holes in the pads, they're through-hole pads. And so I've got the pins here, and they go through the holes. And what I've done is I've kind of like squished that down a bit, creased it a little bit, and taped it to the table, and I soldered it on both sides. Added a whole bunch of flux so I could solder it real quick so I don't melt the Flat Flex, and then cut the rail off, and you end up with that. Looking quite good. So that's going to work quite well, I think. So what we're going to do is got to use the heat gun to peel off that. So what I'm going to do first, because this is the first revision, the holes, which are the locating holes I guess in manufacture, they're a little bit off. It's not going to affect the operation of the thing at all. But what I'm going to do is, for this time, rather than using those holes, by the time you guys download the Gerbers, they'll be perfect. I'll make sure they're perfect because I can double check them against what's here. And I'm going to put some tape so that when I take this off, I can use a tape as a guide. So I'm going to have to get this lined up all nice and perfect, like that, and then down the side as well. Alright, so if I line that up with the tape, that's going to be perfect. Alright, heat gun time. Oh, ow, ow, ow. It's hot. Alright. Actually, I'm not going to take the glue off. I'm not going to bother. I'm going to stick this straight down. The glue is still real tacky. So, yeah. I think it'll be fine. Just to stick this straight on top. There we go. Like that. And there we are. Look at that. Looking great. Slight mismatch on the hole there, but this is the first revision, but that's not going to affect the functionality one little bit. I'll fix that on the version you guys download. But that is looking great. Alright, so I've got another screen that came today. This screen, it looks dimmer than this one and the original. Actually, why don't we just put the LEDs in and run off the bench power supply and see what it looks like. So I got these really thin, tiny LEDs, just from AliExpress. No information on here, but I'll put information down the bottom what you should buy if you want to do this. And these aren't expensive. You can get them in warm white, cool white, and natural white. And these are the natural white ones. So carefully take this cover off. On the original style screens, there's two little tiny Phillips screws, and then the top just comes off. It's real easy. On this one, it looks like it's clipped on, so I want to be a little bit careful. One, two, and three. There we go. And there is our backlight. Sitting right there. So, if we carefully remove that, and it looks like we've got a nice little cavity we can stick our LEDs in. How long do we need it? Oh yeah, it's basically perfect length for 1, 2, 3, 4, 5 segments. Practically exactly perfect. Nice. So I'm going to chop that right there. And now I'll get to soldering and we'll stick that in there. Okay, LEDs are ready to go in. Well, they're sitting in there now. So once the roof clips on, I'll be pushed up against the light guide nice and tight. It's just 2 strips of like double-sided tape, and I left the tape, like kind of backing tape on the last piece there so it doesn't stick into the gap. But that is holding in there quite nice. So with the lid on, it should be quite good. Yep. Alright, same lighting setup as last time. We'll plug that in and get that booting. Oh, it is booting. And hook up the backlight. That is definitely brighter. It actually looks yellowish. Not terribly, not bad. It's a little bit of a retro look. But that actually looks pretty good. Nice and bright. I swear that's brighter than what it was before. But that's not bad at all. So I think I'm going to stick with the LED and get some LED driver boards made. And there it is, all installed. So what happens is when this thing is running on the mains power, it's at full brightness because it's the voltage come into the circuit is at 12 volts or so. Once you pull that out, then it will drop down to whatever you've set because the boost converter starts boosting from 8-ish volts up to whatever you set. The original screen was at 70 candela per square meter, and it used to draw 250 milliamps, around about that, depending on the condition of the CCFL tube and other factors. So at the moment, I've got this set to 220 candelas per square meter, so it's quite a bit brighter, but it's drawing like half the power. If I have this screen set to 70 candela per square meter, just like the CCFL, the LEDs draw a tenth of the power, 25.6 milliamps as opposed to 250 milliamps. So the LED is quite a significant power saving, so that should help with the runtime. So that's all working at the moment. I have to do a little bit more testing with some capacitors and this and that. I'll do that later, and I'll update the schematics. So by the time you're downloading these, they'll be all updated. And of course, we've got the new Flat Flex there. So we are ready to test this thing out. I've got this all cleaned. Cleaned it with isopropyl and cleaned the buttons with the isopropyl as well. Just make sure all your wires are routed correctly. So these, you kind of got a little pin there and it locates that. Make sure these run nice and neat. The inverter cables, they got a loop around. There's you'll see there's a spot there because the screw goes through here. You don't want to pinch those wires. And then of course the wires, the LEDs come through the channel there. Make sure that's all nice and positioned correctly, and I'll just sit that somehow on there. So that's booting up nice. Now this is plugged into the power adapter, so this is running at full brightness, which is about 330 candela per square meter. The original was 70 candela per square meter, so we're running about 4.7 times brighter. Now, in reality, because this was so old, I actually measured the output of this screen at 35 candela. It was about half of the original rated, according to the data sheets I could find. Just because of age, I guess. This thing's like 20 years old or something, so the CCFL tube's pretty tired, which means that this is actually nearly 9.5 times brighter in the raw numbers. You know, 35 candela up to 330 candela. That's about 9.4 times or so. So yeah, this is much brighter. The power draw of this now at 330 candela per square meter is 215 milliamps. The old CCFL was pulling 250. So from factory fresh, we're getting about 4.7 times brighter for a little bit less power. In reality, because of that, you know, the worn out tube, 9.4 times for a little bit less power. Not bad. So if we pull that out, you see it's gone dimmer. Now we're running at 220 candela. That's what I've set it to. You can set it to whatever you want. That's pulling 115 milliamps, which is just under half, for about 3 times the brightness. 3 times from the original when it was brand new. Because it had gone dimmer, we're actually, in real life, 6.3 times. So yeah, it's a much better improvement. So we're using less power for, when this was brand new, 3 times the brightness on the screen. So here I've made a comparison between the 3 different colours of white LED that are available and the original CCFL. I used manual settings in my camera, so all the aperture and the iris and all that sort of stuff is all the same between the 4 samples. I also used a colour checker chart so that I was able to colour balance everything so they're all exactly spot on. My computer monitor and all that is all calibrated as well, so I was able to get these things to look pretty close to real life. They might look a little bit different to real life on your monitor depending on YouTube video compression and how calibrated or how close to ideal calibration your monitors are and all that sort of stuff. But as a relative demonstration, they are spot on. So the warm white looks that yellow compared to the cool white. Like that direct comparison is correct. So on the top left-hand corner, you can see the original CCFL there. That's rated at 34 candela per square meter. That's actually what I measured. The thing is rated to 70 candela per square meter in the data sheet. So that's just faded through time, and that's just how it is. So that's how it's going to sit. So that's our measurement there at 5,800 Kelvin. Little bit cooler than natural white at 5,000 Kelvin, but not too bad. That's our baseline there. On the top right hand corner, there's a natural white LEDs at 70 candela per square meter. So that's, we've set all the LEDs to the brightness as stated in the data sheet, and we're getting 4,800 Kelvin. I think it's a little bit yellower due to the filtering through the polarizing layers and the LCD and that sort of stuff, but that's pretty close to natural white. 4,800. Natural white is generally around 5,000 ish. Bottom left, we got the cool white, which is 7,500 Kelvin. That's quite blue. Cool white is generally from about 6,400 Kelvin upwards. So we are well into the cool white range. And yeah, that is, in real life, it does look quite blue, but it's not too bad if that's what you want. The warm white is over in the bottom right corner, and that is 3,400 Kelvin. It does look very yellow in real life as well. As you can see there, it's I don't like it myself. It kind of reminds me of like the yellowed plastics of old electronics, and it looks kind of dated and yeah, just old. So I went for the natural white, so it's not too blue, it's not too yellow, it's just right, the old Goldilocks zone, and yeah, that's pretty close to the original CCFL, and yeah, it looks quite good in real life. And we got another one. Third one just arrived today. Number 3, because you can never have enough scopes. I didn't buy this for the scope. I bought it for all the accessories. And a charger. Oh yeah. But this one here is an older firmware revision, so we may as well update the firmware. I'm going to replace the screen. The screen is busted as usual. So what we've got to do is pull out that chip right there. That's the one. So this chip's got to be removed. We could either use hot air, or you can just blob up your solder all the way across the pins with your soldering iron, and then that way you can melt the solder all in one go and remove it. Just be careful, because on this side there's two pins. The first pin at the very top right hand corner, as it's shown here, and then a few pins down there's another one where they're pins that aren't used, but if you are not careful you'll lift the pad. It's not a big deal because the pins aren't used. Those pads don't go anywhere. They're just there to for the leg to solder down to, but just be careful so you don't do any damage. So I'm going to take this side here off first, so I can lift it that way slightly and then heat up this side and then take it off. If I take this side off first, I'm going to put stress on here and where those two pads are I was talking about, and they might lift off. But these side here, they're all like a bit more firm on the substrate. It's a little bit of upwards pressure. There we go. You see that pop up? That's all. Don't try and rip it off. So we can clean up these pads. Get rid of the solder that we don't need. I'll check that under the microscope or a magnifying glass, so I don't get my head in the way, but I'll check that to make sure it's all clean, but it's looking pretty good there. Then of course on the chip we're going to have to clean up all that. So once again a bunch of flux, if I can do it without throwing the thing across the room. With a bit of perseverance, a bunch of flux and some attention with the soldering iron and solder sucker, or some braid, you'll have a chip ready to go. So we need to stick it in the programmer. I've got one of these, just the TL8662 Plus, the usual thing, and you'll need the TSOP40A 8-bits adapter and a TSOP3240 48 adapter to go on top of that. So that goes in there like that, both arrows up, and that can go in our programmer. That way. Now, to put that in there, I'm going to have to get my head right in there because the pins are really, really small. And we are ready to go. So I'll go over the computer, do this off camera. Alright, one tasty chip, just been upgraded. That's going to go there, and we'll solder that in. I'll see how I go. I might get my head in the way, so we'll see if there's something to watch or if it's going to be just the back of my head. Alright, I've got one side almost done. I use a drag soldering method up to the end, and I'll just suck that little bit of solder off at the end there. And there it is. If you swear in just the right way, and you hold your tongue in the right position, and the constellations are in the right positions, you might just get it back in as nicely as that. So we're ready to put this thing back together and see if it boots. Alright, moment of truth. Let's see what happens. I'll zoom in there a bit. Well, it's booting. There we go, 1.16, fantastic, thumbs up, it worked. Alright, so to convert this into a 720p, we have to play with a couple resistors. That's all there is to it. You can convert a 710A and a 720A into a 720p. You cannot convert a 710 standard or a 720 standard into a 720p. The motherboard is different. It doesn't have certain parts, and there's no triggering on the input jacks here. And yeah, it's not possible. You also can't convert up to a 730A, which is a 200 megahertz model, because there's other differences as well with some of the transformers and the other bits and pieces. But I believe you can turn a 710 into a 720, and you definitely can turn a 710A and a 720A into a 720p, which is what we're going to do now. We're going to turn the 720A into a 720p. There's 3 changes we have to make in this case. And in the end, if you've got a 710A, it's got to look the same as well, depending on what resistors are actually fitted. So we've got one here that's got to be removed, one here that's got to be removed, and over here we've got to shift a resistor across to a different position. So I'll zoom right in and we'll have a closer look. So you can see R213 here. That's got to come out if it's not already removed. I believe that's fitted on the 710A. 720A it's not fitted. If we move across, where is it? Right there. You can see R207. That's got to be removed as well. This, I believe, is to increase the bandwidth from 60 megahertz to 100 megahertz. These 2 resistors. And then if we move down, right down to the bottom here, right about there, you can see there's 2 resistors, R204 and R205. You got to remove R205, and there's got to be a resistor installed in R204. For a 710A, these may both be populated, in which case you can just remove R205. For a 720A, we'll have to remove R205 and then shift it across to R204. So let's do that now. As always, the flux, the bigger the gob, the better the job. As easy as that. Moment of truth. Let's see what happens. So I'll turn that on and let's zoom in. It's booting. What's it say? 720p. Winner, winner, chicken dinner. It's done. So that is upgraded and hacked. Nice. One last thing to note about this this hack, you'll probably find, if you play around, that if you remove both of those 2 resistors, the R204 and R205, and you boot the scope, it'll boot and it'll tell you that's a 730A. Fantastic, 200 megahertz, 1 gigasample a second. No, like I said before, you need to change a lot of other components, and it's, yeah, generally not worth it, not worth the hassle. I don't know if anyone's actually done it, if they've done the full upgrade. I'm not going to bother. Yeah, so you can make it tell you it's a 730A, but it will not perform as a 730A. It won't perform at its full rated specs. So there we go, all done. Upgraded, repaired, calibrated, and the works. All 3 of them, and I've got a 4th one on the way too. So yeah, these ones are all looking really good. So I hope you found that extremely long video somewhat informative, hopefully a little bit entertaining, and hopefully it helps you get your unit up and running quite well. So if you need any help, you'll find all the links down below. Head over to EEVBlog forums. There's a lot of us over there which will help you figure through if you have any problems, get stuck somewhere. But there you go. We'll see you in the next one.